Hello students, today we will start with a new unit, that is Unit 3 Electrochemistry. We have studied about the previous unit there. Now moving on to next unit, that is Electrochemistry. Hope you have understood the concepts related to solid states. Now the name electrochemistry, a very important concept. See, if you consider any biological aspects, some biological processes that takes place in our body, or some other processes which we study outside, has lots of basic aspects of electrochemistry. So this field is a very vast field and a very interesting field also. And why we need to study about this aspect is because related to this aspect, whatever we study or the devices which we use using the principle of electrochemical principle or electrochemistry principles, they are less polluting and they have lots of applications, and that is why we need to know about this particular concept. Just imagine why it might have been included in your syllabus, since you are all studying the general and basic principles related to chemistry. Let's move on to the concept. Just a general introduction on this topic. Electrochemistry. So when you have this, when you hear this word electrochemistry, something comes to your mind related to electricity and something related to chemistry of it. So electro, something related to electricity or electrical energy, and chemistry means something involving chemical reactions. Using this, let us define what is electrochemistry. Electrochemistry is a branch of chemistry which deals with the relationship between the interconversion of electrical energy and chemical energy. So how electrical energy can be converted into chemical energy and how chemical energy can be converted into electrical energy. These concepts we will be studying under electrochemistry. So let us see how. So first let us define what is electrochemistry. The branch of chemistry or the branch that deals with the relationship, or you can say the interconversion of relationship between electrical energy and chemical energy. This branch is called as electrochemistry. Hope this is clear. Now we will see what concepts are we going to study under electrochemistry. Under electrochemistry, the two important points that you need to keep in your mind is that first we will be coming across the aspects where the production of electrical energy can be done using chemical energy. That is how electrical energy can be produced using chemical energy, that too using spontaneous chemical reactions. What do you mean by spontaneous chemical reactions? I'll explain it to you. So what is the first point that we need to keep in our mind? That production of electrical energy using spontaneous chemical reactions please do try to follow what I'm trying to convey to you. I understand it's not that easy sitting and watching the video and trying to understand the concept, yet you need to adjust to the situation, and so I hope you're getting the point what I mean to say. We are studying the concepts under electrochemistry. The main two concepts I'm just mentioning now, it is that in one way under electrochemistry what we study is electrical energy can be produced using some spontaneous chemical reaction. Now you know what is spontaneous. Spontaneous means the reaction that can take place continuously without a break. The reaction that takes place on its own, we call that as spontaneous reactions. So let me tell you an example for this one. You use batteries or cells for your watches, say wrist watches or clocks, or the torches. We use the battery, isn't it, or the cell. That comes under this category where production of electrical energy is done using spontaneous chemical reactions. What is happening in a battery? In a battery, some chemical reaction is taking place, and that too spontaneously. It is taking place on its own, isn't it? Are you doing something there? No, it does. The reaction takes place on its own, and there production of electrical energy takes place. Are you getting the point now? So this is one point which we study under electrochemistry. One more way, if suppose the reaction is not spontaneous. If the reaction is not spontaneous, we call such reactions as non-spontaneous reactions. So these non-spontaneous reactions can be brought out by using electrical energy also. So you understand, there is interconversion of energy. Chemical energy converting into electrical energy. Using electrical energy, you can also carry on the chemical processes or chemical reactions. That is what I mean to say now. So what is the next point you will be studying here, or you will be coming across? That is use of electrical energy to bring about non-spontaneous chemical reactions. Non-spontaneous chemical reactions. Hope it is clear. So for this one we have example, that is electrolytic cell, we call it as. Electrolysis you might have heard of, isn't it? We use two electrodes, an anode, cathode, and then we connect it externally. Then we pass electric current through it. When we pass electric current through it, some chemical reactions takes place there. The reaction was not spontaneous. That is why we are making it spontaneous using electrical energy. We supply electrical energy and then carry out the reaction which was non-spontaneous. So such processes also we will be studying under electrochemistry. So example is electrolysis. So in electrolysis what happens? We supply electric current. So we would have taken electrolyte, two electrodes will be dipped in it. So there the electric that is the chemical reactions will be carried out. Now for example, you know the use of sodium hydroxide, you know the use of chlorine, you know the use of sodium. So all these, it's not very easy to prepare. So the process of preparation of sodium, say for example sodium hydroxide, you know, isn't it? It is a strong base. It is used in many processes. The reactions which you might have come across now day-to-day life, the soap which we use, all has this as a base, a basic component there. So for the production of sodium hydroxide we use this method, that is electrolytic method. So that is an example. Preparation of NaOH is an example for the second one point that I have mentioned. What happens here? Electrical energy converts, that is electrical energy brings about a non-spontaneous reactions. So you hope you have understood how important this field is, or this area is. Even some chemical responses, say in our body, the nerve tissues or nerve cells, they transmit messages, isn't it? That too is said to have some principles of electrochemistry. So in biological field, that is medical field also, as well as in devices what we use in industrial applications also, this plays a very important role. Now let us study the important types of cells. So such cells are called as electrochemical cells. Okay, the cells that follows the principle of electrochemistry, we call it as electrochemical cells. There are two main types of electrochemical cells we will study, which are they. electrochemical cells are mainly classified, as voltaic cells, VOLTAIC, or they are also called as galvanic cell. One more name is galvanic cell. Galvanic cells, voltaic cells or galvanic cells. One more type of cell is called as electrolytic cells. Electrolytic cells. Now, how do you differentiate between these two cells? So, I have told you voltaic cells or galvanic cells. See the first point which we had mentioned, that is the using spontaneous chemical reaction, production of electricity can be done. So here chemical energy will be converted into electrical energy. Hope you get it. So if we have to differentiate between voltaic cells and electrolytic cell, so under voltaic cell, these cells convert chemical energy into electrical energy. Into electrical energy. Whereas what are electrolytic cell? I have told you, which follows the principles of electrolysis, or electrolysis is an example. So what does these cells do? These cells convert electrical energy into chemical energy. These cells convert electrical energy into chemical energy. So this was the very important point. And here under voltaic cell or galvanic cell, an important example, sometimes they generally call it as Daniell cell also. I'll tell what is the difference there. Now hope you have understood the main difference between these two. Here some chemical reactions will be taking place, isn't it, which is spontaneous, that will be converted into electrical energy, whereas here the reactions which are not spontaneous will be carried out using electrical energy. So we say electrical energy is converted into chemical energy in general terms. And next point what you need to know is, here in this case, anode is a negative electrode and cathode is positive. Here see both types of cells, I will tell you how it is. So in voltaic or galvanic cell, what happens, you know, two beakers will be taken. Here an electrode will be taken. We will study the setup, just briefly explaining. And here it will be externally connected. Okay. Internally also it will be connected using a salt bridge. I'll tell you about that. Whereas in electrolytic cell, you know, both the electrodes will be dipped in the same solution, and then they will be externally connected to the circuit. Okay. So here the anode is a negative electrode. Anode is negative electrode and cathode is positive electrode. So whenever you come across these two types of cells, you must be knowing that when we mention anode, we will mention, if suppose this is the anode, we mention it negative anode, and cathode we will be mentioning it as positive. Whereas in the case of electrolytic cell, it is opposite. Here anode is negative, isn't it? But here anode will be positive. So if this is the anode here, then we will mention it as plus. Cathode we will mention negative, opposite it is. So in this case, how do we differentiate between these two? Here anode is positive electrode and cathode is negative electrode. Cathode is negative electrode. This is a major difference between the two types of cells. We will see other differences also. Here both the electrodes, that is positive, that is anode and cathode, if you see, both the electrodes are fitted in different compartments. Here both the electrodes are fitted in same compartment. That is again a major difference you see. What is it? Both electrodes are fitted in different compartments, whereas here both the electrodes will be fitted in the same compartment. Same compartment. This is one more difference. The next major difference between voltaic cells and electrolytic cells are, that is in this case, that is in the case of galvanic cell, ions are discharged only at cathode. So only at cathode the ions gets discharged. Whereas in the case of electrolytic cells, ions will be discharged in both the electrodes or at both the electrodes. So the difference we will mention that ions are discharged only at cathode, whereas in this case ions are discharged at both the electrodes. At both the electrodes. Hope you have followed the difference between the two types of cells, that is voltaic cells and electrolytic cell. Then finally you can write the example for these cells. One major example for voltaic cell example is Daniell cell, Daniell, Daniell cell is an example. Since I don't have space here, I have written it here. Then for electrolytic cell you can write example is cell used for the preparation of NaOH. Cell used for the preparation of NaOH, that is sodium hydroxide. That is an example there that you see. Next we will see further important terms that we come across in electrochemistry. Further, we see the important term is electrode potential. You have studied this in your class 11, that is first PUC concept. You have studied what is electrode potential, what is standard electrode potential also. Yet we will see what it is. Electrode potential means the potential difference between the two electrodes. So the potential difference between the two electrodes. For example, if we have one electrode here, one more electrode dipped in another solution, then the potential difference, that is the voltage difference, you know, isn't it? Potential, voltage, one and the same. So the potential difference between the two electrodes is called as the electrode potential. So how do you define it? The potential difference between the two electrodes when the metal is dipped in its respective solutions. Now, what you need to understand is, you will take a solution, isn't it? Generally we call it as electrolyte, Electrolyte, electrolyte we call it as. Do you know, if suppose this is iron, then the solution which you have taken will contain iron ion. It will be solution of that metal itself. Now iron sulfate. If this is copper, then copper sulfate. If the electrode is zinc, then the solution will be related to zinc itself, zinc sulfate solution, like that. So what I mean to say is, when metal is in equilibrium with its ion in the solution. Now if suppose this is zinc electrode, then this will contain ZnSO4, isn't it? Which ions do you have? Zn2 plus and SO4 2 minus. So this metal will be in an equilibrium with the ions in the solution. Then that potential difference, what you call the difference between the two electrodes, you call it as electrode potential. So when you mention, you will have to mention that the potential difference between the two electrodes when the metal electrode is at equilibrium. You know what is equilibrium? Equilibrium is the process where the rate of, or equilibrium is a state where the rate of forward reaction will be equal to rate of backward reaction. So electrode is at equilibrium with its metal ions in the solution. So solution means, you understand that it is electrolyte which we are speaking. So this is an important term to understand. One more term is standard electrode potential. Standard electrode potential. Standard electrode potential is, so you know what is electrode potential. Standard electrode potential means the electrode potential that we define at standard conditions, that is at 298 Kelvin, and when the concentrations of metal and its ion, or metal and electrolyte is unity. When the concentration of metal and its respective ions is unity, then the electrode potential, we call it as standard electrode potential. So how do you define this? You can define it as the electrode potential. I'll write it as EP. Please write it completely. The electrode potential when the concentration of all species the species in the solution is unity at 298 Kelvin. This is again a standard condition, 298 Kelvin, when the temperature is 298 Kelvin and all the species has a concentration of 1 unity, that is 1 mole per dm cube, or 1 molar is the concentration, then you call that electrode potential, or the difference between the potential of two electrodes, as standard electrode potential. So this is how you will be defining the important terms called as electrode potential. Now we have one more term called as half cell. half cell. What is half cell? Half cell means, see, I have told you in Daniell cell, that is in galvanic cell, we will have two compartments. So electrodes are placed in two different compartments. Half cell means one part where anode takes place, that is called as one half cell. One more part where the reduction takes place, or which is the cathode part, that is called as one more half cell. So this will be considered as one half cell, this will be considered as one more half cell. Total overall you call it as a Daniell cell. You understand? So metal, that is electrode, metal dipped in its own solution constitutes a half cell. So the metal electrode dipped in its own solution is called as one half cell, or you call it a single electrode. Half cell, you can also call it a single electrode or half cell. The or a is better, a metal electrode dipped in its own salt solution constitutes a half cell. A half cell means one half cell. Hope it is clear. So a metal electrode dipped in its own salt solution. For example, I have told you, if it is zinc, then the solution will be zinc sulfate. If it is iron, then the solution will be iron sulfate. If it is copper, the solution will be copper sulfate. In its own salt solution, the metal electrode dipped is called one half cell. Next, we will see the other important terminologies that we study under this. Sometimes they will ask you which are the factors that affect these electrode potentials. The factors affecting electrode potential. Factors affecting electrode potential. So we know what is electrode potential. So what factors may affect these? One is nature of reactants. What reactants you have taken, they will play an important role in affecting the electrode potential. That can be one factor. One more factor is temperature. Temperature can also affect electrode potential. One more factor is concentration of ions, that is concentration of metal ions. Concentration of metal ions. So these are the factors which will be affecting the electrode potential. These points you need to keep in your mind. Next point what that you have to keep in your mind is anode and cathode. We have spoke about this. So you know the sign convention in case of voltaic cells, in the case of electrolytic cells. Always remember that I keep on telling this, isn't it? Anox, red cat. Anox means at anode oxidation takes place. At anode what takes place? Oxidation takes place. Red cat means at cathode what takes place? Which reaction takes place? Reduction takes place. Okay. One more point that I might have mentioned is that how do you know what is oxidation, what is reduction? So this electrochemistry involves these two important reactions called as oxidation and reduction. What you need to understand is, now usually we say oxidation means addition of oxygen or removal of hydrogen. Reduction means addition of hydrogen, removal of oxygen, we say. But here we will be speaking oxidation and reduction in terms of electron transfer, because that plays an important role. When we say electrochemistry, electricity, electric current, that means it is related to electrons. So we will be speaking oxidation and reduction in terms of electron transfer. So how should we remember? Oil rig, R-I-G, oil rig. That means oxidation is loss of electron, reduction is gain of electron. So oil means oxidation is loss of electrons, reduction is gain of electrons. Gain of electrons. This is how you can remember. So if you do remember these points, then understanding the concept of electrochemistry becomes very easy. So we will further see a general reaction based on this, that is oxidation and reduction, since I have told you. Now if suppose you have a metal ion, say metal, if oxidation is taking place, what happens if oxidation is taking place? There will be loss of electron. So how do you indicate it? Metal is undergoing oxidation. So oxidation means we have one more. If there is increase in the oxidation number, we call it as oxidation. If there is decrease in the oxidation number, we call as reduction. So a metal, if it is undergoing oxidation, it will lose electrons. If suppose it loses one electron, then what happens? It acquires a plus charge. This is oxidation. Reduction means what? And here if it loses 2 electrons, it will gain 2 plus charge. That means it has lost 2 electrons, so it became positive, that is 2 plus it becomes. Now reduction means the metal now accepts that electron which is lost during oxidation and becomes M. That is, say if this is M plus, it gains an electron and becomes M. This is called as reduction. You understand? So I am explaining it this way, that oxidation and reduction, if it takes place simultaneously, we call it as redox reaction. I'm just explaining that oxidation is loss of electron, that is why we have written it outside. Reduction is gaining of electron. This has gained electron here. Here oxidation, the metal has lost the electron. So these are the basic principles related to electrochemistry and important terminologies that you study. In the upcoming videos, we will discuss the concepts related to Daniell cell and further how we can calculate the electrode potential or other important and interesting aspects of electrochemistry.